Okay. Let me see if I'm live. Du-du-du. All right, that's great. Um, Today is day 5 of studying data structures and algorithm, and I would like to go over this merge sorted array and see if I can still, explain it very well. Um, I'm not going to code it out, but if there's time, I'll try and do that as well. So let's check the question again. I'll just come back here and look at merge sorted array. Right. Um, so I'd already solved this question yesterday, but I want to explain it again and see how well I'll do with the explanation. So the question says you are given two integer arrays, nums1 and nums2, sorted in non-decreasing order. So nums1 and nums2, the both arrays are in increasing order from the smallest number to the highest number, because we are using integers here, so numbers are the items of the array, and two integers m and n representing the number of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into a single array sorted in non-decreasing order. So they want us to merge both arrays, right, and still maintain a state of having the smallest to the highest number. Okay, the final sorted array should not be returned by the function, so the function is not going to return anything, but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m element denotes the elements that should be merged, and the last n elements are set to 0 and should be ignored. Okay. Nums2 has length of n. Right. Okay. So basically they are asking us to merge two arrays, right, such that both of them, let me come to my drawing board. So we have an array called nums1. I'll just copy this, nums1, nums2, and then the value of m and n. All right, so here, this is our given values here. All right, I'll just copy it like this. Okay, that's good for the screen here. Right. Okay, let's start with this. I'll use that. So the question says we should merge nums1 and nums2, right? So merging nums1 and nums2 will give us an array like this. So let's just assume that the merge, right? Let me use a bigger, okay, the stroke is already good. So they're asking us to merge nums1. So our final result should look like this. I'll call it merged, right? So we'll have nums1 plus nums2 here, nums2, right? So we are going to merge nums1 and nums2, and then the final length of this array should be the the amount of elements that are in this nums1 array plus the amount of elements that are in this one. Now the question is telling us that the amount of item, right, the number of items that are in nums1 is 3, right, and the number of items that are in nums2 is this n here, right? So whether there are other elements in nums1, we are just going to ignore them and work exactly with this value that has been given to us, which is the amount of elements that we are going to use to perform the merge operation. So whatever it's behind, even if it was 5, 5, 6, 7 going down, so as long as we know that this n represents the amount of items that should appear, that should be used in this operation, this merge operation, we don't really care about the rest, right? So let me just clean this up quickly. So we are going to use nums1, right, of length m, okay, of length m, and then nums2 of length n, right? So meaning merge this merge here, I'm not going to, it's too hard to type every write everything. I'll just call this mg, right? Let me erase this. So I'll call this mg like this. So merge will have a length of n, m plus n, meaning how many items that are, the amount of items that are in nums1 plus the amount of items that are in nums2, so which is m and n. So at the end of the day, right, we want to do this merge in one place. We don't want to create a new array and then have to do the operation within that array, because this will create a new memory in space. But the problem wants us to, still merge everything within nums1. So nums1 will still be equal to the amount of item here, which is m, sorry, here, this m here, and plus the amount of item that appear here, right, which is n, so plus n here, right? So this is really what they're asking us to do. So take every item here, right, take every item in this array, this nums1 array, which will basically be indicated by this n here, this m here, merge it with the n number in this array here. We don't really care about the size of the actual nums, right? We want to know the size of the amount of elements that we are using to make the merge operation. So we don't really care about the length of nums1, neither the length of nums2. Okay, so when we perform this merge, we want to perform it in one place. We want the nums1 to have the final result, right? So how do we perform this merge? Because there is more to it than just taking every value here, right, and placing it in front here, and then taking every value that we want to take here, which is 3, and placing it behind. Our final nums should still be in a sorted form, right? So what we need to do is to loop through, right, to look inside both arrays and compare each element, right, and see which one is supposed to be the smaller one, which is the one that will come first, and then go in that increasing order. Or we can still even look at the one that is the smallest, that is the biggest, and we'll put it at the end of the the final result. Now we know also that the length of this final num here is what is m plus n, so which is 3 plus 3, which is 6, right? So we know the length of n. I'll just pull, let me just clear off this everything here quickly, right? Okay, I'll just go back here. We know our n nums1 will have will be equal to m plus n, m items, right, plus n items. Okay, and the final length of this will be 6, which is 3 plus 3 here, right? So what do we want to do next? We want to insert elements into this array in a non-decreasing order, right, which is basically increasing order. So how do we do that? Well, we first of all, what I would like to do is to start adding the items that are, you know, the bigger ones, right? So I'll start from the big to small. So I'll first of all compare, right? I'll look inside this array here. Since we are you know, merging inside of this one, so this will still, you know, be in one position, but we are just going to use a loop that is the length of nums2 here, right? Because that is the length of the, you know, the amount of items that we want to merge inside nums1. So so here's what I'm going to do. I'm going to take nums1, right? Nums1, create a new array that is of length 6 already. So I'll have 1, 2, 3, 4, 5, and 6, right? So this will be you know, an array of 6 items, right, which will have a length of 6, and that's what I wrote here. So the operation will go this way. Now we'll first start the loop, right? We'll look, since we are merging everything from here into this one, our loop has to run based on the amount of item that we are using to, you know, merge into the second array, or the first one, which is nums1 here. So we'll first start with 6, right? So we'll have a pointer here, we'll have an indicator here that says, okay, we are currently at this position, right? I'll just put this one here. So we are currently at this position. Now what do? We'll compare sorry so we will compare nums1, the last one here, to the last one in nums1 here, right, based on the amount of items that we want to merge. So 3. So the last one here will be, since it is 3, we want to use 3 items, but the index at which the third item is 2, right? So we'll compare 2 here, 2 here. So the indexes will be 2, 2, right? So we compare both of them and we find out which one is the bigger one, right? So if nums1 is the bigger one, we'll put nums1 here, but in this case nums2 item is the bigger one, so we put 6 here. Then we move this to the front again. Now we are at index what? We are index 1. So we compare, you know, we still keep this one in this place because we can't move it yet, right? Whichever one has been merged, we'll move the pointer away from it. So we compare 5 to still 2 here again. We ask, okay, which one is the bigger one? Obviously 5 is the bigger one, so we put 5 here, and then we move to the next item, right? So we are at 0 now. We compare between 0 and item at 0 and item at 2 still, right? Well, item at 0, it is smaller than the one at 2 here, right? So 2 is smaller than 3, so we put 3 here. Then we move the index of 3, right? We'll move 3's index here, and then we'll say again, is 2, right, which is at index 1, is 2 bigger than 0? 2 is not bigger than 0, so no operation really, no switch really happens. So we will just put both items there, right, and then move this one to the front. Now we'll compare this one again. Sorry, we don't move anything here. We don't reduce this. We'll keep this here, but then we want to compare this one here already. Since we've inserted both items, when they are equal, right, we move both pointers. So already this one is at 0, but then we can't compare anything in front of it because we've already reached the the benchmark for this. So we can't move this pointer forward anymore. So we just put the 2 there, and then since 1 is the only one remaining and we can't compare it to any other one, you just insert 1 here, and this would be your final solution, right? So yeah, that is the solution for merge two sums. Yeah, obviously it has more to it. You need to understand how the operation needs to happen in order for you to solve it. So this is the code for it. Here's what I'm doing basically. So I'm taking m and n. So these are basically the indexes that will be moving. These are just the pointers. I should have called these pointers, but I just called it index 1 and index 2, right? And this will be the last item that we want to insert into nums1, right? Because nums1 will be our final value. Okay, so yes, first of all, we want to use the index at nums2, and this edge case here just says that since we've not reached the end here, right, which is where we stop the loop here, so as long as we are still within this range, within numbers that are bigger or equal to 0, we'll continue running this operation, right? And we'll do our comparison. We'll find out which one is bigger. If the first one is bigger than the second one, we insert it. If if an item in nums1 is bigger than an item in nums2, then we insert it at the end. Or if an item is in nums2 is bigger than an item in nums1, we'll insert it at the end of nums1. And we are not returning anything from this solution here. That's what the question says. But at the end of the day, we'll have a sorted merged items of both arrays. And the space complexity of this operation is based on the inputs basically. So we are not creating any other arrays here. So we have two lists that have been inserted, and lists automatically have a space complexity of O of n, right? A linear space complexity. But in terms of time, right, this is still based on the every operation here is still based on the length of this item here. So whether the index of the second array is 2, 3, 4, 5, it will take as many operations to complete this, right? So the factor here is this value here, and it is not constant, and it is not quadratic increment. So it doesn't increment quadratically. Is that a word? I don't know, but yeah, what I'm saying is this operation is dependent on the value of this index 2. So as this index 2 increases, the operation would take as much time to complete, right? So yeah, that's it for um, merging two arrays. Now, I would like to do the second one that I couldn't complete yesterday. So let me just delete everything here. All right. So we have a valid palindrome question here. So let's take a look at the valid palindrome question. All right. I tried to solve it yesterday, you can see, but I wasn't able to get to the answer that I needed. But we'll try and see if we'll try again today. If I'm really not able to solve it, then I'll look at the solution and see how it is done. Okay, so a valid palindrome. A phrase is a palindrome if, after converting all uppercase letters into lowercase letters and removing all non-alphabetic numeric characters, it reads the same forward and backwards. Alphanumeric characters include letters and numbers. Given a string S, return true if it is a palindrome or false otherwise. So here we have a man, a plan, a canal, Panama, which is true, right? This is true, but the reason why it is true is because it's a palindrome. It reads the same way forward and the same way backward. So meaning if we removed all spaces, comma, and these columns here and converted all of the characters in this string into lower cases, then even when we reverse the result, right, we will still have a man, a plan, a canal, Panama. It will still read the same way forward and backwards. So what does this really mean? For something to be read the same way forward and backward. So let me use a shorter string, right? I'll say RAR, right? RAR, if I wanted to write this backwards, it means I'll have RAR. Or let me start from the back. I'll say RAR like this. This is still the same, right? I can, for us to even visualize this better, right? Let me do it this way. I'll say this R, this is A, and this here is R, right? If I were to move this R to the front, I'll still have R, A, and R, right? So both reads the same, right? Both of them are read the same. This RAR is still the same as this other RAR. So this means that this input here is a palindrome, right? It is a valid palindrome. Now, how do we really how can we determine, right, without logically, which string is a palindrome? Which string is a palindrome? Well, one thing I said yesterday was to create first of all, a reverse is basically a change of position, right? And position is index. So the item at this index here, which is 0, this is 0, this is 1, and this is 2, right? So the item at index 0 should still be R, right, when the string is reversed. Although we know this R is 2, right, but the value itself, right, this R used to be 2, right? So but the value itself is still the same as this R here. Okay, and the same thing goes for A. A used to be index 1, right? But what item in our original array in our inverse array is at index 1 is still A. What item in our original array is at in our inverse array, sorry, right? In our inverse array is at index 2 is still R here. Let me go over that again quickly. Right. So we used to know this is our original string, right? I'll call this original O prime. Or just say original O, right? And this is the inverted one or the reversed one, which is O prime. Now, what item, right, is first in our original string, right? It is R. But what used to be the value of this R? This R used to be at position 2, but now it is at position 1 and the value is still the same. So our new string, our new string after reversing it still has an item at its first position which is equal to the item in our original string, the first item in our original string. And the same thing goes for A, right? A is at position 1 now. A, what position A used to be in? A used to be in position 1, right? So A is still at position 1, and this this green this orange R used to be at position 0, but now it is at position 3. But what item in our string used to be in position 3 is still R, right? So what I'm thinking is to create a map, right? We have a map here, and then in this map we want to match each item from our from our previous string, right? We want to create a map of every item and their indexes. So I'll do something like this. I'll say, okay, well, I have R has a value of, so let me just represent our map like this. R used to be 1, right? And then we have I used to be 0, sorry. A is 1, and which one is here? And then R is also 2, right? So let's do it that way. Okay, R is 2. Now, how do we compare this with each item in? So what do we compare this map to, right? We want to compare it to the inverted version of this, to the reversed one, sorry. The reversed one basically is the item at the last index. So if we know the length of this array, right? This string, sorry, we are not using array. If we know the length of this string, here, right, then we can just say the length minus 1 will be the last item, right? The length minus 1 will be the last item, and the last item should also have a value that is the same as the one we created in our map, right? So if we look at the last item in our array, what we are saying is the last item here should have a value which is equal to the first item in our original string, right? The reason why I'm doing it this way is I don't want to run a loop within a loop, so I'm just going to compare it separately. I'll create a map, right? And then I'll say, okay, now I'm at this current R3 here, right? Okay, let me just say R1, sorry. Well, what do we have here? So this is still R2, sorry, R2, right? Good. So when I compare the reverse of this string, right, the last element here should be the first one here. So the value of this R2 in this map here should be equal to 0. So we know that it was the one that used to be at the first position. Now that we reverse the string, then we started from behind, right? So we started from the back. Reversing something is just going from front to back, right? So if R2 is 0, then A1's value should be what? Should be 1, right? It should be 1. And R1's value, which is here, right? Our R0's value should be equal to what? Should be equal to 2, right? Because it used to be at this position here. So that's it basically. Now, how do we code this? Well. We need, in Python, you can't have duplicate keys, right? Which is why I added each of these as, I added a base to each one of them. So we have R2, R1, and R0. So the value of each one of these should actually have like a base, right? So this will be R0 here. This will be A1 still, and this will be R2. So the value of now our inverted list, right? The value of this R2 here should be the value of R0 in our actual dictionary, right? And so on. So we compare each one of these. Right, let's jump into the code and let me show you a solution. Now I started it here, but I'm not going to use that same solution again. This is actually not correct, but because I have a clear vision of the next direction that I'm heading, wait, sorry, it took the light. Okay. Oh my god, I hope my stream doesn't end. Okay, then let me just, so we have a playground here. I would use this playground for my solutions, test cases, and so on. And sorry. Okay, so here we go. Now we said we'll first of all create a map. What's happening? Oh, I think my camera went off. I don't know if I can bring it back. Properties, stream webcam. Okay, and bring this back. All right. Okay, we are back now. So yeah, first of all, let me create the dictionary, right? Our map. So I'll call this maps. Let me call it a hash map. Just some fancy word, right? a hash map and set this hash map, sorry, and set this hash map to an empty dictionary, right? Now, this is an empty dictionary, and what we need to do here, so we'll create a loop, right, for each item in the string. For I in S is our string, right? Then we also, there is an issue, right? So another thing we need to put into consideration is this. The question says, when after converting all uppercase letters into lowercase, right, into lowercase, and removing all alphanumeric characters. So we need to also put that into our solution. So how do we do this? Well, when we are transforming our string into a dictionary, we need to make sure that every value, right, every key in our dictionary here is actually a string or a number, whatever it is, in lowercase, and not anything like a like let's say an @ sign, right, a comma, a semicolon, and so on. And also any empty spaces has to be removed. Okay, so let's go back and do that. Let's create our dictionary. So first of all, we need to check if the current element is alphanumeric, right? So I'll say if the item at the character at index I, right, the character in the string S at index I, right, dot is alphanumeric. Yeah, this is how you find alphanumeric characters, right? So let's see, return true. Yeah, if it is alpha. So if this is alphanumeric, right, first of all, let's convert it into low. Okay, I'm not going to convert it to lowercase yet. I need to make sure that it is alphanumeric. Then I can convert it to lowercase. So I'll say is alphanum. Then let me just set this to I'll say current. Let me just set this to a key, right? Since it's going to be a key in our dictionary, I'll just say key, right? Let me just say hash key. I'll set this to hash key and say this is equal to so our hash key is going to be the lowercase of this character, right? And then I also said we'll add a base to it, right? R0, R1, A1, and so on. So we'll do it that way. So we'll say we'll do, okay, so I'll say SI, right, dot lower, okay, dot lower plus J plus I. Now this will create a key for us, right? And I don't know why. What is this warning for? Expected support index slice got str instead. Well, I don't know what you mean, bro. Oh, okay. Sorry. I'm taking each item in I in this instead of the index. So I'll do range. Sorry, I there was not the actual item from it's not the index but the item from the string, for a character from the string, right? So here's what I'm going to do. From range length of length of the string, right? Then this way I'll now get uh everything. So I here is an integer, but I want to transform this to a string, so I'll say str, right? Stri. Will this work? Yes. It's not used. Okay, so this works. And what I'll do next is I'll now add each of these as the key in our hash map. So I'll say hash map, right, at hash key, at hash key plus equal, at hash key is equal to I, right? Now let's see if we've created our hash map. I'll just print this at the end of the operation, the loop. Then I'll have my hash map here, hash map like this. And yeah, so let's go ahead and print this out. So let me print. Okay, I need to call the class, the function. So I need to create an instance of the class. So solution, let's say result, right? Result is equal to this solution here, right? So this creates an instance of the solution. Let me just say print the result dot is palindrome, and I'm just going to use my own screen, the RAR, right? That's my test case. So I'll just run this, and you can see we have R0, A1, and R2, right? Great. Now, so we move on to the next step. What are we doing in our next step? Well, in our next step, we want to compare the last item in the actual string, right? The last item to the first one here, right? The last item to the first one. So if the last item here, if the last item is at the same index as the first one, the index of the last item is at the same index. No, sorry. If the value in the actual string, in the reversed form of the string, right? Wait, what am I saying? Let me go back here. Let me see. So what I'm saying is, if this is a reversed form, right? So R2 is now at the beginning, or we can even say sorry, let me use my stylus. So let's really visualize this very well before I go into this one here. Let me just erase. Oh no. Okay, doesn't matter. Okay, so let's come back here and put this here. All right, so we have R0, R1, and so on, right? So we want to compare now. If R2 is, the last item here, right? So I'll do R2 here, right? We'll still create R2 and then find out the value of this R2 in this our string here. And we'll do that for the subsequent one. A1 is A1 value the same as the current position where A1 is? Because we are reversing, right? The values will start from 2 2, 1, and so on. But we still need something to represent. Wait, because we are reversing, right? We are going from R2 to R1. So the reverse index of the string is going to just help us create R1 and R2. But what we are really interested in is R2, right? R2 hmm. Well, this is getting out of hand, because now I'm seeing some you know I mean, logically this actually makes sense, right? But code wise it's actually not straightforward, because if we're looping backwards, right? If we're looking backwards or looping behind, right? We are starting from an index 2, then we go 1, and then 0. If we are using our original string, right, which is r a r, then we need to create a ah then we need to create um a key with which we'll look into this um this loop here, this map here, right? So we want to create a key like R2, and then use this R2 and check the map, right? And see where R2 is. So R2 will be at 2 here, right? But our current, what does 2 really mean to us here? 2 is our the current position in this, the current position in the reverse. So iteration um the iteration key when we are reversing, right? Let me just represent this with a green color. So we have 2, 1, and 0, and this will be R2, right? And then this, the value of R2 here, what's the value of R2? The value of R2 is 2, right? 2 is still here like this, but that's not what we are looking for. We want the value of R2, right? The value of R2 to be R0. So how do we get R0? How do we get R0? We want the value of this last item to be the same as this first one here, and this first one here is R0. What's from this reverse are we going to use to check R0? Interesting. Okay. Um. This is interesting, because we still want this to be R2, right? While we check it against R0, right? If we're checking R0, then All right. Okay. So, um, this is interesting. The only reason why we need to put a base here is because we can't just say map, map, and try to access R, right? This won't work because this map does not have R. It only recognizes items keys as R0, R1, right? So there needs to be a base. And the reason why we are even adding a base is because a map cannot contain items with duplicate keys. So if we were trying to create a map without these bases here, then the map will just ignore the second R, right? It will not even add it there, or it will replace the first one with the second one, which is something we don't want. So how do we go about this? Um RAR, so we are starting from the back here, and we want this to be equal to the first one here, right? What if we do this at index 0, index 2, right? And nothing here says 2. Okay. Wait. What if this is interesting? Um let's even start. What is R2? R2, right? This R2 from our original string. The R2 from our original string is the last item. Last item, right? Last item. And what do we really want from the last item? Well, we want the last item to be the first item. So we want the last item here, right, to have a value here that is equal to 0, right? So last item should be first, which is what a reverse basically means, right? Last should be first, and then first should be last. And then first here is R0. So how do we make this last one now our R0? Should we do R2? Oh, hold on. What is 0? 0 here, right, should be equal to R2, right? This item, the last item here. R0, sorry. R0 should be equal to R2. R2. This I here, this 2 here is just the last index. So how do we get this when both of these ones are already equal? What am I really looking for? What's missing? Like that one. Wait. Obviously, we can just. Hmm. This is interesting. Um, let's see again. I'm just going to erase this quickly. Let me just erase everything from here. Right. Let me just erase all of this. This has to make sense. 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 We have RAR. This is our original string. A reverse of this would be, let me just put 0, 0, 1, 2. The reverse of this would be RAR, RAR with this to be 2, this is 1, and this is 0. Why did we create the map in the first place, right? So what? Wait. If R2 here, right, has a value of 1, has a value of 0, then it means it's at its first position here. If R2 in our map here, but R2 does not have, it's R1 that is at index 0. Interesting times. I really believe this should work, but I don't know why it's difficult, in code. Okay, let's use a value that is not a palindrome, right? I'll say BAR, bar. Now, writing it backwards will be RAB. The only reason why this is not a palindrome is because this B here is not the same as this R here, and this R here is not the same as the V here. So because when it's reversed, right? When it's reversed, it has to be read the same way. So reversing this did not give us the same word, right? The word changed. So what does this really mean? All right. It means if the value at the last index here is not exactly the same as this value here, then we need to forget about it. So if this was a map, right, we create B0, A1, R2, right? If this was a map, and then we loop through the original string, right? We loop through the original string, which is still bar, but we want to start from the end. Then when starting from the end, right? The value of this, the index of this in our original string, right, has to be 0. So we know that it always appears in the first position, right? But in this case, the first item in our index, in our original string, is no longer R. It is B, right? So B is not the same as R. The more I think about this, it just really, you know, goes away. I thought I got it. What if we use the keys, right? The index instead as, so we start 0. 0 um is B, 1 is A, and then 2 is what is R, right? So this is bar, right? And what we want to do next is when we are looping backwards, right? Right. So the last item here, so let's start from bar. I'll just go R A B, right? R A B. Okay, because I'm using a backwards loop, I'll just do bar again. I'm starting from here. This is my starting point here. If I use, although this is my starting point, I don't want to use the index here because this will be 2, right? This will be 2, even though I'm looping backwards, this will be 2. But 2 is not the same. 2 is basically, uh, you know, the key of the value R here. So if I use this, I will have to have like a pointer somewhere, right? A pointer that will decrease each time. Oh my god. They took the light. Ah! No fucking way. Oh my god. Oh my god. Please don't end my stream, please. Please don't end my stream, please. I think I got it, right? I think I got the solution. Oh my god. I think I got it. I am so sorry. I don't know. That's how things happen here, right? That's how we roll. They just take lights. Oh, okay. So I was saying if we had a pointer, right? We start our pointer from 0. Okay. If if the map at pointer 0, right, is equal to this value, right? If the map at pointer 0 is equal to this value, then it means here it is a valid palindrome. But looking at this map at pointer 0, right, is B, right? But we're at R here, it is not equal to this one, so we just say cancel. It is not. So in the case of RAR, right? So this is what will happen. So we set it 0 is equal to R, 1 is equal to A, and R is equal to sorry, 2 is equal to R, right? So our pointer will go this way. So our pointer will start from 0, right? And we'll set we'll start from the last item, which is R, right? So is the map, sorry, I don't know, I'm just rushing. Is the map at uh, the pointer, right? Let me just put pointer P. Is the map at pointer P the same value as this one here? Because we want to make it as unique as possible. I think that is the solution. Yes, it is. Honestly, it is. That's the solution. And then if it's not, right, if it's not the same, then we just return false, right? I think that will work. I strongly believe that. So we already have this, our map here is wrong, right? We don't want to do it this way. Our hash key instead has to be the index. The index. Sorry. Our hash key has to be the index instead. So our hash key has to be the index, and the value will be s at I, right? After checking if it is, alphanumeric. So let's run this. So we can see we have 0R, 1A, 2R, right? So, yeah. All right. So this is what I would do in my second iteration. I want to loop from the back. So I'll say for I in range. Now we're starting from the end, right? In range, let me use J not to, in order not to confuse myself. So J, right? So J in range of, we want to start from the end. So length of S. Sorry, my microphone is blocking my eyes. Length of S minus 1, right? And then we want to, because length of n, we want to stop at, the first element, which is 0, right? So -1. Now, we need a third argument, right, to tell it how to jump, the steps to take, right? So this will be, -1, and then we'll do it this way. So I think if this works, I have to give myself some gifts, which is some time to, I don't know what I'll do. Anyway, so I would say the reverse, right? So we want to, I said we'll have a pointer, right? So pointer will be equal to 0, right? So we'll say, again, we'll still have to do this check. So if the current item that we are looking at, if s at j, right, dot is alpha num, right? Oh, we also want to convert this to lowercase, so that's lower, right? If it is alphanumeric, right, we want to see is, hash map, right? If it's lower, then what is it? If hash map at, at the pointer, right? Pointer, if hash map at pointer is equal to, if hash map at pointer is equal to the last item that we are at now, so we have s at j lower, right? Wants to get the lower case. No, let's say if it's not, sorry, if it is not the same, then let's just return false, right? Let's just return false. If it's not the same as this, let's just return false. Otherwise, if it is, then let's increment our pointer to the next one. So let's check the next one, plus equal 1, right? And then I'll do this. I'll say, so yeah, after the second loop is done, right, and we didn't hit the case where the pointer is not the same as the lower, then we'll just return true, right? This will be true. Okay, so let's see. Yeah, it works. So we have true for this. Let's just try this out in how do you call it, in LeetCode. Right, this solution did not work yesterday. Here, let me run this again. This did not work, and I know exactly why. So let's see if this one will work. It worked for RAR. Let's try bar, right? Let's try bar, for instance. Let's try BAR. Does it work? No, it doesn't work for bar. So I'm pretty confident that this will work. I am very, very confident. What happened? If wait, what's the data type of our hash? Sorry, print hash map. Okay, numbers. All right, that's good. Let me read this again. It says what if hash pointer dot lower blah blah blah. There is a key error here. Um. So. This is interesting. There's a key error. You say if this, right? Okay, what if I said if pointer is because we are incrementing pointer should be less than the length of the string minus 1. If pointer is less or equal to the length of the string minus 1, right? Because we want to hit the very end. Okay, no, yeah, we want to hit the very end. So yeah, so we'll do this. Alright, run. Hey, sorry, and this, sorry, and this. Minus 1. Jesus. Right. Does this work? No way. What's happening? Hashmap pointer. It's a key error. Key error. Wait, let's try the test cases, right, and see which ones. I mean, this is like kind of a cheat. Well, I'll see which ones is. Race car is not a palindrome, so you return false, which is correct. I think it's probably this empty string, right? This one is a palindrome, so let's see if this is also going to return true. If this return true, then it's definitely the edge case for the. Oh, I see. So what is the issue now? So we have 0 up to a man, a plan, a car, ma. Okay. Let's see. There's a key error. What key error is that? Okay. What's going on? Plan. On line 18. Line 18. It's just telling us where the. Okay, so line 11 is where the actual error is. If if hash pointer, so what happens here is this will increment faster than this is. So if since we are increasing, right, we want it to reach so if the pointer is less or equal to the length of s minus 1, right? And sorry, I'm nervous. And this, right? So this will make sure that once we go past the it's still there, right? Same pointer. What's it with pointer? Can I not say hash map, at 1, for instance, right? At 1, right? Oh, this is also a key error. So hash map at 1, would this work? It didn't. This is insane. This is insane. Okay. At 0 it printed, right? Hold on. I see. So we went from 0 to 2 to 3. Okay. Meaning the pointer is not actually what we think it is. Oh, shit. Okay. Sorry, why did I say that? I'm so sorry. But I see. So use sneaky. Okay, what if I don't use I, right? And I still just go ahead and use um and use pointer, right? Just increment pointer, okay? Increment pointer every time I loop through. So pointer plus equal 1. What if I do that? Now it is correct. Now it is true. Okay? Okay? Look where we are now. Look where we are now. Alright. Let's see if this will work. Fingers crossed. I don't want to look. What? Riska is incorrect. How? What's happening? There is no way that Riska is not correct. Oh, I see. We don't really care at this point, right? This will still work regardless. So No way, it didn't. Right, at this point, I think I should just. I don't want to give up, right? But then I'm still wasting time. Whose time am I wasting? I'm not wasting anybody's time. So I really want to know, like, the actual solution to this. I want to come up with my own solution. Right? What's the problem here? This is returning false, right? Instead of true. So it's not really a code problem. It is a logic problem, right? It's a problem with my code instead of right. Hmm. I can't do that. I possibly can't. Wait, let me look at this race car again and see why it is misbehaving. Honestly, I thought I had it, but I did not. I'll be so pained if my solution doesn't, you know, work. Be really pissed. I'll be sad. It says true, meanwhile it's not. So why did it say true? If we look at the last item here, this is R, right? R has a value of, although this will make sense that the pointer is storing a value here, but you can never trust. This is not the issue. That's not the issue at all. What if it is? Well, this is within this scope, so it's not really the pointer's fault. Um, R is equal to R. Then the next one, when pointer is 1, right? Let me print pointer here and see what pointer is. Print pointer. You see? I said it. I said it. Oh my god. Pointer is not nice. Pointer is not nice. Pointer is not our friend, guys. Pointer is a traitor. Pointer 1, pointer 1, pointer 1. Then I can now have another pointer here called pointer 2. Pointer lied to us. I'm sorry, pointer. You liar. You lied. You lied to your friends. Right. This is our answer. This is false. Oh my god. Moment of truth. Let me see if this Panama one will be true. Huh? How? This should work. Oh, damn. This should work. Pointer just our second pointer just went 1. Yes, we're going 0 0 2, and not 1. What happened to 1? How is this jumping from 0 to 2, 3, 4, 7? This doesn't make any sense. Oh, okay. We only increment it when necessary, right? We should only increment it when necessary. So yeah, this is correct now. This is correct. Ah, yeah. Let's see. Please, LeetCode, please. I want to provide my own solution. I want to provide my own solution. Please accept it. Accepted! Yes! Okay, let's submit this. Although it's an easy question, right? I don't know. Most people will be like, oh, why is he rejecting over that? But I mean, I came up with this solution myself. So, yeah, please. It's not the best solution, but it has been accepted. Ha! Congratulations to everyone who has participated in this. This is awesome. This is awesome. This is it. Solved it. I mean, in terms of memory and space, it's I don't know. I still feel somehow I'm not using any memory here, and I'm using two loops. Basically, eh, I don't know why it's still bad, right? I doubt this is actually. Let me see what somebody else did, right? So I'll go to Python. I mean, I'll understand it in any other language, but it's easier for me to stay with something I'm familiar with. So what is this? Is using regex. Okay. To check every number. It's reversed. The string to lower. What's this type? Okay, so this is just typing the values. String to lower. Reversed string, right? And then if reverse string, if the string is equal to the reverse string, uh well, this is just leaving Python to do the comparison itself, right? I'm looking for something else, like more of logic. More of logic. More of logic. Okay, 2 pointers, bit 90. Interesting. Let's see. But boasting of their solution, I feel pretty bad. I feel bad right now. Simple 2 pointer. Everybody's. Oh, this one claims it's easy. Let's see. Well, all of them are using pointers. But anyway, let's see what this is. This pointer is. Right, so we have left and right. The string here. While left is less than right. And then wow, oh boy. This is not good. This is not good at all. Right? This is not good. Left is superior to right, so the right index is superior to left. So it's starting from the end, and the left is basically the start, which is 0, and then the right is the end, which is the length of the string minus 1, right? So if it's 3 items in the string, that right will be 2, right? So it says while left is less than right and not s left is not. Oh, I see. S left is not alphanumeric. Oh my god, they've started again. Alright, I think I'll have to end this stream now. I don't have power anymore. Um, alright, we shall converse some other time. I'll just try to bring this one back.